Okay, so what we're going to look at here is factoring by grouping. Okay, now when I say grouping, we're talking about like the grouping symbols, such as we're going to use a parentheses. So the idea with grouping is that we're going to group the first two terms together and group the second two terms together. And then we're going to factor out, similar to what we did in the first video, we're going to factor out the greatest common factor of the first two and the second two. And what that's going to result in is eventually we're going to be able to show two binomials multiplied together that would be completely factored. But if we multiplied them, that would give us back what we started with. Okay, so again, we're undoing the multiplication. We're breaking apart the polynomial into its two factors. Okay, this is just one of the ways we can do it, and it's actually going to tie in with what we did in the first video to be able to factor out quadratic trinomials. Okay, so looking at this guy here, we're going to group the first two and the second two. Now, I just want to point this out here. It would always be good to include the sign that's there in case there's a negative, because we don't want to miss out on the negative, and then just kind of put a plus sign in the middle, okay, to remember that we're adding the two, we're not multiplying the two. Because if we ever have a negative, we don't want to miss out on that sign, because if we lose out on the sign, it's going to make a mistake and we're not going to have what we want, okay? So it's just a good habit to get into here. So what we're going to do now is we're going to factor out the greatest common factor of the first two. So what's the largest number that goes into 5 and 5? Well, 5, right? Do they both have an n in common? Yes, they both have an n, so we want to take the one with the lowest exponent, in this case n squared. And just like we did in the first video factoring out the greatest common factor, we're now going to divide out 5n squared from both terms, okay? So we're treating it like we don't even see this guy right now. We're just factoring out the greatest common factor of the first two. So with that in mind, 5 divided by 5, those guys go away. N cubed divided by n squared gives us n. And then 5n squared divided by 5n squared, both of those go away. But even though it goes away, I have to put something in that place, right? So what number is really there if they both cancel out? Well, 1, right? Anything divided by itself is 1. So 5 divided by 5 is 1, n squared divided by n squared is 1. So what we're left with here is just 1. Okay, now in the second one, again, we're treating it like we have a plus sign here, and I'll show you why in a second that it's important to have that plus. What can I factor out of 2n and 2? Well, they both share a 2, right? Do they share an n? No. So I'm only going to factor out the 2 from both. So dividing that out, 2 divided by 2, I'm going to be left with just n. 2 divided by 2, just kind of like we saw in the last one, that's going to give me a 1. Okay, 2 divided by 2 is 1. So the reason I wanted to show you this is if we're doing things right, these two should be the same. Okay, these two should be the same. Okay, now what's neat about this is because they are the same, we can actually factor that out. We can take that out, bring it to the front, and multiply it by what remains. Okay, so we're going to take this completely out, move it to the front, and multiply it by what remains. In this case, what remains is the 5n squared and the plus 2. Okay, so now, let's see if I can get rid of this real quick. Okay, so now what we end up with here is a binomial times a binomial. This would be completely factored, and if I multiplied this through, I would get back what I started with, okay? So let's actually check to see if that's right, okay? So let's multiply this through. We've talked about foiling before. So if I multiply n to 5n squared, I get 5n cubed. If I multiply n to 2, I get 2n. If I multiply 1 to 5n squared, I get 5n squared. Right? 1 times 5 is 5, and we have our n squared. And then the last terms, 1 times 2 gives me 2. Okay? Now, this isn't in standard form. Remember, we go from highest exponent to lowest exponent. So if I put it in standard form, we'd actually have the cube, the square, the 2n, and the 2, right? So this would actually be our standard form. Now compare that to what we started with. If I kind of get rid of some of the lines here, is that what we had? Yeah. So that's the idea behind factoring by grouping, okay? Is we're able to group things together, factor out the greatest common factor, the first two, the second two, then factor out the term that they have in common, bring that to the front, okay? And then that's going to be multiplied by what remains. So let's try maybe 2 or 3 more. Let's try this one. Okay, so this is where I said that negative sign can throw things off. So we're going to group the first two and the second two, but keep the sign with it and just know that we're really adding the two. This is a multiplication. You can think of it like we're adding a negative. Okay, so keep that sign with it because that's important. Okay, so now with that in mind, okay, we're going to factor out the GCF of the first two. What is the greatest common factor or the greatest thing that I can possibly take out of 30 and 48? Okay, well, in my mind, I'm thinking 6. Okay, so let's try 6, and then if it's not the greatest common factor, we can always go back and try to factor something else out. Okay, so if I take out a 6, do they also have an x in common? Yeah, they have x cubed and x squared. Well, we want the one with the lowest exponent, so x squared, and we're going to factor that from the first two. So dividing that out, we have 6x squared from both terms. 30 divided by 6 is 5. X cubed divided by x squared is x. Remember, subtract the exponents, we get an exponent 1. And then we have 48 divided by 6, and we get 8. Okay, so plus 8. And then what happens with our x squareds? Well, the x squareds go away, right? So we just have 8. Well, let's check here. Does anything go into 5 and 8? No, just 1, right? So we took out the greatest common factor with the 6, so we're okay there. Okay? Now, also look at, this is why I said it's important to keep that negative, because when I look at the greatest common factor of the second two, are both of the terms negative? Yes. So that's why I wanted you to keep that sign there, number one, so we don't make a mistake, and then number two, we can actually factor out a negative number from both of these, and then we can just make everything positive, okay? So if you can factor out a negative, notice we have 2 positives here, that's what we're going to want, because our second binomial we want to look like 5x plus 8, okay? So factoring out, what is the greatest common factor I can take from those guys? Well, I can take out a 5, and since they're both negative, I can actually take out a negative 5, right? Do they have an x in common? No. So we're just going to take out the negative 5 from both terms, okay? So what's a negative 25 divided by a negative 5? 5, right? And then we still have the x. Then negative 40 divided by negative 5 plus 8, okay? So again, notice this is what we wanted. We wanted both of those guys to be the same. If they're the same, what we can do is take it to the front. We're factoring it out, okay? It's kind of like I multiplied that term to each one. Think of your distributive property. It's essentially undoing the distributive property. We're factoring it out, and then we multiply it by the 2 terms that remain, okay? 6x squared and the negative 5. So 6x squared minus 5, okay? So this would be as far as we can go, and this would be our solution. Let's try maybe 1 more, maybe 2 more. Well, let's see what we're on time, and then we can do the rest in class, okay? So on this one, okay, we have 80p cubed plus 20p squared. Group these together, addition in the middle, okay? Now, if we have addition here, it's not going to matter, but I'm just trying to get you in the habit so when we have the negatives, you know how to do that. Well, for me, it looks like 20 goes into 80 and 20, so I'm going to factor out a 20. And then they both have a p, and the lowest exponent is 2, okay? So I'm going to factor out a 20p squared from the first two, okay? So if that's the case, if I have 80 divided by 20p squared, 80 divided by 20, we'd have 4, and then we'd be left with p. And then 20p squared divided by itself would just give us 1, okay? Anything divided by itself is 1. Then in the second one, since they're both positives, we're going to keep that positive here, and we're going to factor out what goes into 140 and 35, okay? Now, if you're not sure, you could come over here and try to make a factor tree, okay, if you weren't really sure. For instance, I could say, well, 14 and 10 goes into it, and then 2 and 7, and then 2 and 5. Well, I'd have 2 times 2 times 7 times 5. That would be the primes. And we could also break out 35 and see what goes into it, which looks like 7 and 5, right? Okay. Well, notice both 7 and 5 go into both, right? Well, what's 7 times 5? 35. So 35 actually goes into 140 and itself. So 35 would be the greatest common factor here, okay? So you don't have to do this, but if you're ever lost, you can make a factor tree and see what they have in common. But we can actually factor out 35 here because it goes into both, okay? So I'm going to kind of distinguish that that's not a part of what we're doing at the moment. So 140 divided by 35, if you have your calculator, you could do it, or just use long division. You should get 4. Okay, so 35 goes into there 4 times. And then if we divide that out also from itself, sorry, I forgot to write here, we end up with 1. So again, notice these guys are the same. That's what we want. So think of it as the reverse of the distributive property. We're going to take this out, factor it out, bring it to the front, and what remains is what we want in the second parentheses. 20p squared plus 35. Okay, let's maybe try one more just to get some practice, maybe one with a negative if we have one. Okay, number 2 does. So let's try number 2 real quick. Okay, so factoring the first 2, factoring the second 2, understanding that we're adding it. Okay, so now what is the greatest common factor of the first 2? Well, I know 3 goes into 21 and 3 can go into 24, so let's try 3. Okay, do they both have an m? Yeah, and the lowest exponent is m squared. Okay, so I'm going to factor out an 3m squared from the first 2. 21 divided by 3 is 7. M cubed divided by m squared is m. 24 divided by 3 is 8. And the m squareds go away. Okay, now again, this is why I wanted you to separate the two, because notice these guys are both negative, so we can actually factor out a negative from this. We want to factor out a negative so that we end up with 2 positives here. Okay, now what's the greatest number that goes into 7 and 8? Well, almost nothing, right? Can you think of any common factor that goes into 7 and 8? Well, that sounds like that'd be a problem, right? But here's the thing. If you can't ever factor out a greatest common factor, you can always take out 1, because doesn't 1 go into everything? Yeah, 1 goes into 7, 1 goes into 8. So if you can't take out anything else, you can always take out a 1. So we're going to factor out a negative 1 from both of these and see what we get. What's a negative 7 divided by a negative 1? Positive 7. What's a negative 8 divided by a negative 1? Positive 8. So again, notice these two are the same. So I'm going to do the reverse of the distributive property, factor out 7m plus 8, okay, and multiply it by what remains, 3m squared minus 1. Okay, so this would be our solution. Okay.